Before I proceed, though, I would like to show you what has happened on the summary menu. Remember that before, when we just plotted the variable and we clicked on summary, it gives us the average, the median, the mean, the quartiles, the maximum value, the minimum value. If you subset your data by state, as we have done over here, and you click on summary up here, see how great this is. This will give you the average, all the summary statistics per state. Okay, so you will get all the values per state here in case that you want to consult them. So it's usually a good idea to jump back and forth between plot and summary. And then inference usually includes other variables that we can use depending on what you're visualizing. But the summary tab gives you a lot of very interesting information. It also gives you the sample size, obviously. Sample size here is the number of counties on each state. So that's something that can also be can be compared, right? So this is super useful. So the summary statistics change depending on the variables that you have over here. If you only have one, it will only show you the summary statistics of that variable. If you subdivide it, then it will show you the subdivision also on the summary statistics. Anyway, what I was going to show you is that I'm going to remove the subset. So I'm going to just click here and click on none, all right, just to remove the subset and go back over here. Now, sometimes you're interested in exploring the relationships between variables. So for instance, my guess is that there is going to be an interesting relationship between income per capita per county and percentage of people who have college degrees. My prediction will be that the higher the number of people, the percentage of people who have college degrees, the higher the income per capita would be, county by county. So let's test that. I'm going to go to select second variable over here, open this up and select here college 2014. And this will generate a scatter plot, right? A scatter plot is a plot that shows you the relationship between two continuous quantitative variables. On the x-axis, we have people who have college degrees. 0.5 means 50%. So it's 50%, 60%, 70, 80, 90%. So the position on the x-axis is proportional to the percentage of people who have college degrees, county by county. And then the y-axis, the vertical axis, is income per capita, right? So the higher a little circle is on the y-scale, the larger the income per capita. So we have some interesting outliers. For example, there are counties over here which have a relatively low percentage of college degrees, but their income per capita is super high. For instance, this one, 25%, around 23% of people have college degrees, but income per capita is relatively high. And then, you know, but in general, the relationship is positive. The higher the percentage of college degrees, the higher the income per capita is. The relationship is quite clear. Sometimes the direction of the relationship, in which case a positive relation, the more we have of this variable, the more we have on the second variable, right? Sometimes the relationship goes up, but it could go down. For instance, if we compared, I don't know, poverty rates versus income per capita, the relationship will be negative, because the higher the average income per capita per county, probably the lower the poverty rate will be, right? So in that sense, the relationship will be a negative relationship, right? Sometimes statisticians talk about a correlation. A correlation is a positive or negative linear relationship. This means that we could trace a line over here going across all the circles, showing us the direction, the average direction of the relationship. Fortunately, we can plot that directly with Insight. I can go to add to plot, okay, up here, add to plot. Open this upper menu over here and select trend lines and curves. When we do that, we could select linear model, and that will trace a horizontal line that shows us, this is called the line of best fit, which is the line that better describes the underlying data. If we could more or less average the positions of all these points over here, the result and trace the result will be this straight line over here. Now, sometimes a line is the best description of the direction of the relationship between two variables, but sometimes it's also worth overlaying, for example, a cubic line, which is it will be a curve. You will see that there you go. So this line over here shows us that the relationship is not perfectly linear. It actually goes upward a little bit as soon as we get to the outliers over here, right? So these are methods of exploring the data even further. There are also different kinds of smoothers, right? If you're familiar with this term in statistics, right? So you can select also the color of the smoother, etc., right? So these are the ways of overlaying trend lines in scatter plots.